Hello everyone, myself Vignesh from NMAMIT Engineering College. Here we discuss about the project presentation of home automation which was taught by Jayalakshmi N from the Emertxe group. Let's discuss the basic overview of the project. The main objective of the project is the home automation by using IoT. Let's also discuss about the Arduino Pixim Lab simulation and how we arrived to the conclusion of the home automation in the later slides. The basic programming language used for home automation is embedded C programming. They taught us C programming from scratch and also introduced us to the various data types such as integer, character, and string, also the modifiers and the qualifiers. They also taught us about the conditionals such as if else, and also the loops such as while, do while, for loops, etc. They also taught us about the operators which are used in C and also how we can use arrays and pointers, also about the functions and the storage classes and also the preprocessors. Preprocessor is where we can include the header files in the C language. Next comes the microcontroller where they taught us about the ADC analog to digital converter and also the digital to analog conversion, how we can implement these two blocks in our project. And they also taught us about the timers and the counters which is normally used for producing the pulses as well as the generating some delay, etc. Next week they also taught us about the pulse width modulation, how we can control the intensity of light using pulse width modulation, and also about the processors, memory, and also the input output ports used. They also taught us about the difference between the microprocessor and the microcontroller. The main difference is that microprocessor consists of a CPU, whereas the microcontroller consists of CPU as well as RAM, ROM, and other peripherals in a single chip. Next, they taught us about the embedded system. Now, what do you mean by embedded system? Embedded system is a combination of hardware and software that performs the specific task. There are, there are types of embedded systems are listed below like standalone, real-time, networked, and mobile systems. They, later the components used in the project and also the requirements we need to meet by doing this project is the project must be reliable, cost effective, it should consume low power as well as it should be fast processing. Next, the elements of the project here we discuss is the light control, temperature control, as well as the water level control. How we can control those things according to our needs. Here are building an IoT-based home automation solution, which includes the components like garden lights, temperature system of the home, and also the serial tank control. We control these three things in our project. Usually the garden lights or during the day it should be off and during night the garden light should be on. And let's see how we can control this by using the various sensors. Here we use Arduino Uno controller board as well as the Pixim Lab simulator for simulating these three elements, and we are also using Blink IoT to send the notification or as well as we can control these three elements in the mobile app. The main objectives of the project is to control most of the devices at home using our phone and also to provide an easy and comfortable way to control their home devices from any place and also receive the feedback or the notification about the status of our home. Now, what is Internet of Things? The Internet of Things describes physical objects or a group of objects with sensors as well as the processing ability, software, and other technologies that connect and exchange the data with other devices and systems over the internet or other communication network. In simplified version, it is nothing but connecting the various sensors through internet and receiving those data about the devices. Next, what is the need of home automation? People usually are outside the home for many reasons like traveling and they want to control some devices from far distance. For example, filling the water tank, turning off the lights in the room, or else about the temperature around the room, etc. So here we implement the project using the Arduino. The Arduino Uno is an open source microcontroller board based on microchip at Mega 328P microcontroller. And this board has 14 digital input output pins as well as 6 analog input output pins and is programmable with IDE. And the Arduino supports the languages like C and C++, and we should follow the syntax of the code. So here we implement the here we write the code using C uh, in the Arduino. Now we discuss about the Blink app configuration. How we used Blink console or the Blink app. How do we create the template using Blink app and how we added the device in the Blink app, and we also selected the various data streams in the Blink app, and also we should include the Blink library in the Arduino IDE programming. Now comes the PiximLab. PiximLab is a real-time emulator of development boards with integrated MLABX AVR GDB debugger. PiximLab supports some Pixim microcontroller. PiximLab have integration with Arduino IDE for programming the board's microcontroller. This is nothing but we program in Arduino and we simulate it using the PiximLab. We import some ports in the Arduino and we also choose the port in the PiximLab and we configure it and we simulate in PiximLab. Next, the different stages involved is nothing but the C programming and microcontroller, embedded systems, and IoT and Blink. Now, let's discuss about the project. Here we control the garden lights using the LDR. So, how we can control the garden light is during the day the outdoor light is maximum. So the LDR sensor detects the light and the light must be turned off. So same during the night the outdoor light is very low. So the LDR sensor detects the light and the light is turned on. LDR sensor is nothing but the light detecting sensor which detects the light that falls upon it. It is usually the photoresistor and it is nothing but the light controlled variable resistor. The resistance of the photoresistor decreases with the increase in the light intensity. In other words, it exhibits light photoconductivity. A photoresistor can be applied in light and dark activated switching circuits. The LED lights are connected to the LDR via the analog to digital converter. The analog to digital converter converts the analog input by the LDR into its equivalent digital form and which is then converted by certain formula as a upper bound. Based on this, we glow the LED. Next, we control the temperature sensor. The temperature sensor used is the LM35 sensor, which is analog value, so it should be converted into digital value in terms of binary. so that actual temperature is calculated, and we can and it is calculated using the value of the voltage. Here we implement heater and cooler. The temperature can be regulated using the heater and the cooler. The heater increases the temperature while the cooler decreases it, and the readings are shown in the CLCD as well as the status of heater are shown in Blink app, which must be installed in the Android phone. And the Blink app controls the temperature using the Arduino Uno and gets the reading of the temperature, and also sends the notification whether the temperature exceeds 35 degree or not. If the temperature exceeds 35 degree, the heater is automatically turned off and the notification is sent to the Android phone using Blink app. Next, the Arduino controls the temperature system and supplies the reading to the Blink app, and it also displays the temperature on the CLCD. And the CLCD is responsible for the display as well as the status of the temperature. Later, we implement the water control using the uh, Arduino Uno. This setup consists of two valves. One is inlet as well as the outlet. The inlet valve is used for controlling the inflow of the water into the tank, and the outlet valve is to eject the water. The tank refills itself when the outflow exceeds the minimum value of 2000 liters and gives notification to the Blink app. Also, it stops filling the tank when it is 3000 liters. If it is below 2000 liters, the tank will automatically fill. The serial remote tank is a tank simulator controlled by a serial communication protocol. Implement the serial tank controlling mechanism. The tank has several sensors and the actuators that can be read and controlled using the communication protocol. Thank you. Let's implement the home automation project using Arduino IDE as well as the Blink app and PiximLab. The code is compiled for errors, and also it is exported to a binary file. Let's open PiximLab. We should import the binary file in the PiximLab, which is already done, as well as we should include the serial tank. We should connect the port of Arduino, same as the Arduino for the serial tank. We should also implement place the LCD here as well as the cooler, etc. Now just let's run this code. As you can see, when I press the reset button, the code starts implementing, and the water in the inlet for the tank starts filling, and we can also note down the volume in the CLCD as well. Similarly, we cast the Blink mobile phone screen, the Blink app phone screen inside of this, where we can also turn on the heater, and in the CLCD it shows the heater is on, and also it shows the temperature. Now also it shows that the temperature is above 35 and the heater is turned off. Similarly, we can turn on the cooler in the phone, and the cooler is turned on, and we can see the temperature is decreasing as well. Similarly, we can turn off the cooler, and we can see the cooler is turned off and the temperature remains. Similarly, we can also see the volume of the serial water tank in the Blink app. Similarly, if we turn on the outlet, the water starts decreasing. We can see the volume can also be read in CLCD as well as the Blink app, and in the CLCD shows the outflow is on. Similarly, when we decrease below the 2000, you can see inlet is also warm, so we can turn off the outlet, and the tank starts rising again. And also it shows the volume in which it is increasing. And after when it is full, it also shows the inlet is off. Similarly, when we can also see when it is high, the light will glow in, and when the LDR sensor is in low, the light turns off. Similarly, cooler can be on by using the mobile app. When we press cooler on, the cooler starts spinning, and in the CLCD it shows that the cooler is on. Okay, that's it for today. Thank you for the opportunity provided.